Hello there, good afternoon, it's Heider again. Welcome back to one of my videos on the OMAP series. Today we're going to talk about the board's I/O pins and how to get all LEDs working on this pin. And in fact, I think it's going to be a really useful thing for you to do or to learn is if you have a different board, Texas Instrument board, or if you have a different processor altogether, or different, EVM, they call it the EVM for evaluation modules. This video will help you to identify which pins are the output, and if there is enough time, we'll also do the input pins as well. If not, or if there's not enough time, we'll probably move the input side on another video and we'll take it from there. But for now, this video hopefully should help you to identify what pins are there, or how to activate all those pins all together. So without further ado, let's just get started. So just to continue, OMAP video 5 that I uploaded yesterday on YouTube is the startup of all this. So if you want to understand what we did in the past, or what the screen is all about, you can look into the OMAP video 5 that I uploaded yesterday. This is a continuation on the project that we did yesterday. So yesterday what we did, we went through setting up the board, setting up the clock, setting up the UART, and also coming up with output on here at some point. So now we have we're pretty much going to carry on this one, and as I said before, we're going to build on top of the project until it becomes a really sophisticated project later on. So this is a continuation. So let's carry on with this. Now, if you remember yesterday, we discussed stuff about how we interact with GPIO. Sorry, no, we didn't say GPIO. How do we do sysconfig? Today, in either for us to work with the I/O side, or talking to the pins, or the input-output pins of the system, we will be interfacing or working with something called the GPIO, or the general purpose input-output I/O. So GPIO is the drivers that are used by TI to enable the chip to talk to the outside world. So that includes, if we go into this, into here. So obviously, as you can see now, the OMAP is this chip over here, as I'm pointing at now, and it's got a lot of other chips on the evaluation board. So you got dip switches, that's fine. You got the LEDs in here, all 4 of them. So you got 1, 2, 3, 4. You got a switch 1 and you got switch 2 here. Where's the switch 2 gone? The switch 2 is here, and you got this switch is for reset, and you got all other chips all together. So each chip will do different function. One of them will do VGA, one of them will do UART, you name it. Just the whole thing is kind of integrated together, and we just need to tell what chip, what to do. But I think the easiest and simplest thing to begin with is to kind of start talking to the I/O pins. Unlike other products, this is an Arduino board. Arduino is really simple. It's like the start. It's not even close to a starter to a main course. This board, basically, you launch, and you on the setup function, you just tell it basically, pin mode is output or input, or pull up if you like, and then you do digital write high or low to the pin, or if you have a PWM, you can say, for example, I want to read or write analog data. So it's all kind of a couple of functions, it's all done. So this is Arduino, you can do a lot of stuff with it. But on the OMAP, it's a different story. OMAPs, you'll see in a minute, is a more complex. There's a lot of configuration to do before you can be able to talk to the pins, and I think it's also to do with the compilation process as well. I mean, if it's you can, I think, in theory, you can kind of write a different package call, or if you different software development platform altogether, that would look like Arduino and will do this whole thing in the background like what Arduino does. Yeah, you can, but I think to use the what's been cooked for you, let's just pick it up and move from there. So I've talked too much. Let me just carry on now. So back into the thing. Now, in order for us to talk to GPIO, we have PDK, the PDK library we need to utilize. So PDK, GPIO will be somewhere on the drivers. So we talked about UART. We're going to close that now. We've done with the UART. And now we're going to pick up on the GPIO side. So GPIO, what we need is GPIO.h, and we need the what's it called, the socket as well, and we need so I think we'll probably need the socket, and we'll need the other interface as well. So I think for now, so we'll carry on with this and we'll see how it goes. So for now, let's include, actually I like to start with a space to isolate from what we did yesterday. Just going to move my keyboard slightly. Yeah, so TI, as you can see here, so you go in TI, TRV, GPIO, yeah, and the one we are looking for is GPIO.h. So that's the first guy we need to load. And the other one is, we'll need the socket. So what's in the socket? We need GPIO, let me just think, is it the source or the socket? I think it's probably the source in here. Yes, definitely need this one, GPIO socket.h. So GPIO, and you got the socket, and GPIO underscore SOC dot h, and the next one we need the SRC, and on the SRC folder there should be a V0, and I'll explain that in a minute. So V0, and you've got this one, GPIO V0 there. So GPIO underscore V0.h. I didn't write the GPIO header files, as you can see. It's all done by Texas Instrument. If you have issues or would like to find out why am I doing this, you need to refer to the documentation and understand what's been documented and how this whole thing is being put together. But obviously I've done this a few times, and I know these are the drivers we need. So in either I'm not going to recompile again just to save time, so I'm just going to jump back into let me just go back into this one. So now yesterday what we did init board, and under init board we put these a few lines in here just to get the board up and running, and obviously to allow us to see stuff on the serial port, and we called the function on here. Today I'm going to do something similar. Actually, I'm going to do void init GPIO. I'm just going to do GPIOs in case there's a GPIO there somewhere, and I will call it here. You can call it whatever you like. I'm just calling it into GPIOs because I like it. Yeah. So yeah, that's fine. Now we are here. And now with the GPIO stuff, all you need to do is pretty much you run in a GPIO at some point, and that should pretty much. So if you do GPIO init, notice the I, how they wrote it is a small I. So now this should kind of get you halfway there. There will be errors when we compile, as you can probably know why, because obviously what we did in here on the CFG, the one we did yesterday, you also need to allow GPIO to be to actually load up in here. Now the GPIO is a package, so what you need to do is you go into here. So let's say GPIO, and we're going to load the package. Let's just double check the package name, just in case you wanted to, you know, you're intrigued. So under TI DRV GPIO, where's it gone? There we go. Right? And this is our guy. So TI DRV GPIO, right? So now this is the package now we have loaded, and you have to, on the documentation as well, it says enable equals false. You have to do this according to the documentation. And finally, actually I would like to put that here instead. So GPIO.settings.device sock type, I think it is, equals the one that's got OMAP L138, which is when we did device name yesterday. So we're going to do that here. So GPIO is configured, right? That's all done, and we're ready to go. So if I compile this now, there will be another error. Let's just go through this here. We'll compile now, and you'll see what happens now. So now we are just basically just wiring up our development environment to be able to start speaking to the GPIO. But because we haven't told her what GPIO is all about, or what, we didn't define the GPIO yet, the system is going to say I'm looking for a library that I can't find, and this is where people just really scratch their heads. And I've seen tons of people online kind of looking for what that means, the error we're just about to see. And yeah, so this error now, you'll see it happening soon. I'll explain what it means and how to solve it, hopefully. So yeah, we'll just wait for it to compile. Only 13 minutes so far down the video. That's pretty good. I think we're getting close. Again, you can skip. Oh, there we go. So now we got an error, and that's what I've been waiting for. So let's have a look. Don't proceed. Don't want to upload it. Good. Now, where are we? Compiler failure, line 99 fatal error, cannot open source file. Okay, hold on a minute. That's a different thing. So TIDRV GPIO SRC GPIO v0.h. Let's see, why is H capital out of interest? Let's just have a look at this. Into the code. Right. Oh, what's this? It should be small. Thank you very much. Let's just check the files. So just be in case. So GPI.h, where has it gone? So GPI.h, all small, it's good. Sock GPIO underscore sock.h. Sock GPIO underscore sock.h, exactly. And then SRC SRC. I think we're missing something. Yeah, SRC slash v0. Yeah, SRC v0 and then GPIO v0.h. So it's probably the missing bit. Okay. Yeah, let's compile again. Let's go say hi to her. Yeah. Okay, so don't proceed, thank you. Yeah, now you're thinking undefined symbol stuff is referenced by a library, and that library is nothing to do with you. Is the GPIO v0 dot this, right? Notice the GPIO v0 config has nothing to do with or does not exist really in any of the libraries, and I actually searched that, you know, up and down. I kind of dumped all the libraries I might have shown you this on the previous videos where I actually wrote a file that lists all the functions within the libraries. This function does not exist. Don't waste your time. You can include the world, but it's not going to happen. Eventually, what I found out is, which is, well, pretty much undocumented, but maybe I missed it undocumented somewhere. This is where you should be defining your stuff. So this is where you are telling the compiler information about the GPIOs, and you know, if they're inputs, if they're outputs, if they're interrupts, that sort of thing. So this is something you really have to define in your code. And now I'm going to take this copy, so copy it there and back into the development mode, and here we're going to start. So at the moment we have these two functions. We're just going to go above them, so we need this somehow in here somewhere, right? But obviously this is C, and you're going to have to define it somewhere. So how you define it, you say GPIO pin config, right? And then you say the no, hold on, this yeah, pin, just a second. Let's just park this a bit on the side here for a minute. So eventually the system needs to see this somehow, somewhere, right? And you don't have that installed somewhere. So what we're going to do, we're going to start configuring the system. So GPIO pin config, and let's just say pin conf or configs. Let's just call it pin configs, and it's an array. Okay, the array will have stuff in it, and this is where it gets really interesting. So at the moment I wanted to say pin 1 is GPIO CFG output. Okay, and that's pretty much it to tell the system I'm using pin 1. But because this is just a number, you're going to have to add some salt and pepper to make sure that the compiler understands it as an integer 32. Otherwise, if this is like 64-bit and this is 32-bit, it can cause a bit of a chaos. So what you need to do, you cast it as an integer, and you put a U in front of it like this. So U is it's sorry. Sorry about that. The phone call, right? The missus or the boss. Anyway, yes. So what we're talking about? Yeah. So yeah, int to make sure that this is a 32-bit, or int how int compiler define int, and then you put number 1 over here, and then you would say U for unsigned integer. If you don't put that U, what that means is, if you go, for example, let's say it's an 8-bit integer. 8-bit means you can go between 0 to 255 if it's unsigned, or between minus 127 and plus 128, or sorry, plus 127 and minus 127 for a signed bit. So U means it's unsigned, and we definitely need to do unsigned at some point. So pin number 1 is GPIO CFG output. Now, to be honest with you, nobody knows what pin number 1 does, or it's, well, you don't know what pin 1 is. I don't know what pin 1 is, but just for the sake of it, I'm just going to write data into it. Yeah. We don't know if this is going to be the LEDs, and the purpose of this video, as I said, is to discover where LEDs are. but for now we just need to tell the system to kind of, can I write to GPIOs or not. So to begin with, that's step number one. Okay, and afterwards what you need to do, you would need to kind of create the callback functions. So this is where you would, this is your definition. So if you wanted to have another pin, let's say I wanted to have pin number 55 and also output, and I wanted to do, for example, pin 70, pin 45 as input. That's how you do it. So now these are pretty much directly interfacing. Now just be aware, I've seen other videos, I've seen a lot of codes where people uses macros, which I haven't, wasn't been a great fan of. You would have something like a GPIO device config. So for example, rather than having it like this directed, say I want pin 45, some would say GPIO device config, and they would say the pin port number, right, and the port number. Let's just call it let's just call it something. So LED port and LED pin. I think that makes sense to read. LED port number and LED pin number, right? And then you finish that config, and then you carry on exactly the same way. You just take that, copy it into here, so you know what's happening. Now that is a macro, and for some reason when I fired that up, I think it can be confusing. Use it when you can, if you like, but obviously you need to find out more about the pins, what the port is, where the pin is, that sort of stuff. You can do it this way. I think my method is pretty much straightforward, is a lot easier to kind of identify. Also that macro sometimes works, sometimes it doesn't. Sometimes it does not return a value, and you end up having a 0 there, and nothing works, and you just wondered. A lot of people would start playing with these values and increase and decrease all that stuff, and nothing happens. You're lost. And the possibilities are, this is a 32 bits and that's a 32 bits, so multiply 32 to the power of 32 or times 32. You end up in so much mess and combination that you don't really know where to start. Unless you know exactly where you are, it's going to be really hard to use this way to begin with. So I am not going to do this, and just delete this like that. And let's just take our simple example by doing exactly this. So we're going to configure just one pin only, which is pin 1, and we'll carry on this way. So now notice we haven't done anything to this yet, and we did say the compiler, as you can see down here, is looking for it, right? That is something we're going to configure. So this, what we just did here, is part of that. We'll come and tell it in a minute. So the next bit, or the next part, is GPIO callback. You have to define that, and you would say, for example, my GPIO callbacks. Same thing. But this is let's say you have 10 pins over here. One of them is input, well, let's say pin 1. Let's just say we have this as an input rather than an output. I would say, for example, I wanted to go like this, whatever, and then here, above it somewhere, I will have to define a function to receive that stuff. So whenever someone on that pin, it will trigger the function, but there's a configuration and setup for this, so we're not gonna. This is out of the scope of this conversation or this video, which we'll have another one later on to discuss to describe all the pins and the inputs and the interrupts. For now, because we're not doing much, we're just going to say nil. We're not interested in doing anything else, right? So this is basically in a nutshell pretty much almost it. Now what you need to do now is GPIO v0 config, and you just get that in. Sorry, v0, not v0 config, right? And you just want to call this so GPIO v0 config. Yeah, I will just yeah, okay, that's fine. Let's just do a v0 config like this, just to define it this way. And I'm going to do an array of, it needs that first one, what pins we're talking about, their interrupts, okay, how many pins we are using to, how many pins does this guy uses, and currently, as you can see, is only one, so we're just going to say 1. How many pins does this guy uses, and we're just going to say 1 or nil if you like. That's not a problem. I like 1 and nil. It's not it works for me. And then eventually a 0 for the priority. Keep that 0 always, unless you know exactly what you're doing. I wouldn't mess with this this variable. So this is priority. Keep it always 0. It means default standard. It'll work. So now, in theory, this whole thing should just compile and work fine. Mind you, we haven't done anything yet. We haven't told it to. So let's just compile. We haven't told it to start input or output. We might have an error on this one. I think I might need to change the spelling of some of the stuff, but I think we're good. It should just work fine. Yeah, build finish, and now it's going to upload to the system, and you'll see another couple of lines, appearing on the thingy. Wonderful. So, hallelujah. So now we have this. Let's just clear the screen on this one. Actually keep it, doesn't matter. Right. So now we are good to go. We just need to say to the system, start writing stuff to it, and read stuff from it if you like, if it's an input or depending on input and an output. So this is how you set up your pins. Now, I think things you need to really know and be aware of and understand before we carry on and move any further is why or what these values mean and where the heck they come from. If you don't know, really simple, notice, this is for you in case you also like to hack stuff, and I like to hack stuff myself and understand how they work. So notice we included these 3, okay? So let's pick up on this one and see what is happening in there. So TI, DRV, GPIO, and we are looking at GPIO.edge. So now if you scroll down, it will explain pretty much everything, well, I won't say explain, but I would say it will list everything you need in here with, if someone knows what he's doing, he probably can work things out. The bit that you're interested in is this bit here. So what we said is GPIO CFG output. You can say STD or output. Notice both STD and output are exactly the same because they are both the same values. So if you write STD or you write output, is the same thing. So when you go on the internet and look for code, some of it says out STD and some of it says output. It's the same thing. You can see it here on the code. No PLL, sorry, no pull. It means, anyway, it's like Arduino. You can tell it, I don't want to pull up pin, yes or no, that sort of thing. So in here you have a pull up and pull down. depending on how your resistor is set up and how your pin is all working. So CFG's output should be absolutely fine, should just work. You can say the high is the 1 and the low is the 0, as you can see in here. So you just basically tell the pin to be high or low by doing 1 or 0. In here you've got the different types of outputs. Input in here you've got the in, no PLL, and the other bit we'll talk about later is the interrupt stuff, which we'll do later on. But anyway, I think that's enough for what we need to do. And also, just to touch on what we did yesterday, in case you wondered about the clocks and stuff like that, and if you wanted to go to board.h as well, I didn't touch on that yesterday, so I wanted to say in exactly the same way. What is pinmux? Where does pinmux come from? You got a lot of stuff in here. The definition of what the board should be. Where the values are, what they mean, that sort of thing. So you can read the stuff in here. I think sometimes you get better answer on the header files than searching, Google and trying to find out things, of what someone else did. So if you just read the header files, it probably makes sense in a minute. But it's up to you, really. I mean, however you want to do it. I like to do this. And I also like to do even deeper by looking into machine code and stopping the device halfway breakpoint and then carrying on this way. I like hacking things. Anyway, so board is we're done with. GPIO, I don't think we need any more, so that's fine. And also, by the way, the function we're about to use also on the GPIO.h as well. So, but for now, this is what we need. And if we just carry on this way, so let's just go. So now we initted the board, so the board is up and running. We also initted the GPIO, as you can see on these two functions. And all I want to do right now is write to the pin. So if I go into here and say, for example, GPIO right, and I would say 0, 1. Now, here's what people get confused about. GPIO right, it needs two parameters, the pin and the it's 1 or 0, high or low, basically. So now we're telling it to switch on of 0. Now what does that 0 means? And this is what people get confused about. The 0 here, and why are we having it as 1 over here? So this is pin 1, but we are saying 0 on the bottom, and you think surely something wrong. The answer to this, and this is what I said earlier on, it's not the same as Arduino, as you can see here. You're not going to say directly, I want this to be output and this to be input. What you're saying is, I'm defining an array in here. Where is it gone? Where did I lose it? Yeah. I'm defining my array, and the array which has the pins that I'm interested in working with, and the first element in the array, which is number 0, arrays in C starts from 0, by the way, is this pin over here. So pin 0, index 0, element 0 is the reference to pin number 1, which is this one. So always remember, this function will only talk about stuff 0 referencing in whatever you define in this v0 config. Yeah. So this is the part that you need to realize and understand. Otherwise, you're gonna have problems. But this is basically hopefully this will help you to kind of work out what we need to do. So if I now if I look into the board, I got pin. So 0 is off, 1 is on, 2 is off, 3 is on. Yeah, and at the moment, if I just go and say to the thing to write number 1, which is an output to the pin, so which is put it to high, one of the LEDs should change, but that is of course if you have got 1 correctly. So in other words, for the argument's sake, if this is the if your OMAP here is connected to the first LED, say, or the fourth LED, whatever it is, on pin number 1, then this code should absolutely work fine, and you'll see the light changes. The chances are, with the lack of documentation and difficulty finding where each pin goes, is where people are getting confused and kind of getting frustrated. And I had that conversation with many. I did help them up eventually, but this is basically, imagine you wanted to trace the pin, so you're gonna put a even if you wanted to trace the pin, you're gonna put a voltmeter here, and then find you use it in a, what's it called, in a one of those things when you touch the diode mode, basically, but a beeping kind of diode mode, where you touch the pins of the voltmeter and it beeps if it's connected. So it's called the continuous connectivity mode of the voltmeter. So basically, you touch the pin in here. But the problem is, notice the OMAP. There's no pins around it. It's a BGA type. All the pins are actually underneath. And just to show you in particular what I am talking about. Don't hold with my hand, sorry, just give me a second. This is the OMAP chip over here, right? If you notice, that's the, let's put it on this camera. Let's just zoom onto this. And in fact, I'm going to put some lighting on. So here we go. That's the OMAP chip, as you can see, there. Right? There's no pins around it, but the pins are all on here. So I'm going to use that later on in my project. I'm going to solder this in, using my BGA. Yeah? Very clever. Very clever. Anyway, so this is the OMAP itself, and I've got tons of them in here with me. Right, so switch this off. Back to where we were. So yeah, I mean, if you try to put a voltmeter here on one of the pins to read where it goes, it's impossible. You can't. It's all underneath. You need to take the chip out and do all that kind of stuff, and it's a pain in the neck. You won't be able to do that. So the easier way, or the software development way, is to do it differently. I'll show you that in really less than a minute. I just wanted to, I'll show you that now actually. So now, as you see, if I write 1 to this pin number 1, yeah, I should have something power up. So let's just run this code and see what happens. You'll see nothing will happen because I think pin number 1 goes to something else. So build's finished, looks good, no errors, no warnings, beautiful. Yeah, so that worked, and we're back to thingy. Now, I just wanted to walk you through a little bit stuff here. This is the reference manual for the OMAP L138. Notice the chip I just shown you now, the BGA, has got, think about it like an Intel CPU. Think about it like this. Let's just pick up one of the CPUs I have in here. Let's pick up this one. That's the CPU, right? So you've got the first part. So the CPU is split in 4 sections. Section 1, 2, 3, 4. Yeah. So now what we're looking at on the left hand side is the top left section of the square of the OMAP. Yeah. So now, if you look at this, every single pin is described. So you got from A to Z. This is the rows, and the columns go from 1 to 16. So 1 to 20. So 1 to 10 over here, and 1 to 10 on the other side. So part number 1, you got that stuff. You can see here that little point, that little description on the chip. And part 2, part 3, part 4. The problem is, let's say you wanted to write onto, this will describe a lot of stuff in here. So what that means is, the video ports do out, that sort of thing. Every single pin in the chip, it'll tell you where is it mapped to. But when you have the board, knowingly you have 4 LEDs on, you'd expect to have someone that says LEDs on the pins here somewhere. So if I kind of go into search for LED, yeah, and notice I see UART, receive, SATA, LED, GPI, so GP11. GP1 of 1, it means you take the 1, multiply it by 16, and then add 1 to it. Read the manuals, you'll understand what I mean. So anything GP number and then bracket number means you take the first number, multiply by 16, and then add the second number. So that means pin number 17 physically. So if I go back into my code and tell pin 17 to be input and output, input or output in here. So let's just look into this, and I'll say pin number 17, right? And I'm going to save now and run again. I should have an LED change. Now we're just going to zoom onto this bit here. Notice we still have not changed the status of these 4 LEDs. So you got 0 off, 1 on, 2 off, and 3 on. So just running the code now. Build finished, and now it's compiling. Yeah, see that? Nothing changed. The pins or just to be on the safe side, or just to be 100% sure, let's say it was already 1, let's just put it to 0, okay? Right? And then run again. I'm just focusing on the board. Run third time, nothing changed. Yeah? So that tells you the documentation. It's going back to the documentation itself. Expanding that. And if I keep searching for LEDs, I'm out of the table. That means there's nothing saying anything about LEDs in there. And this is a bit frustrating, because now how am I supposed to tell the LEDs where the LEDs exactly are mapped, and why they're not connected, why they're not documented in here somewhere? You got all that stuff in here. That means, is this accurate? Is this out of date? Do we have the LEDs there or not? That you have. I spent over a couple of weeks just trying to find out what is going on. Why we got 4 LEDs? Why none of them are documented in here? That sort of thing. So I think if TI is reading this video, please, and I love you. I love your products. They're brilliant. They've got so much potential, used by so many. It would really make sense if you guys can come up to say, in the documentation somewhere, pin 0 goes to VGA port or goes to LED. So at least we can tell that yes, this is correct. We can just go and test it this way. Anyway, back to the stuff we are working on now. So now let's get the documentation out of the way, because obviously you can see it's kind of out of sync. It's not really going anywhere to power up the board. So what's the solution then? Which pin is the right pin? Again, according to the documentation, the system will only have 144 pins, and you know, if you remember the chip I just showed you now, it's got 140. It's got pretty much a lot more than 144, but 144 is GPIOs, and one of those pins would definitely be the guy that talks to the you know, the LEDs there. So what we need to do is I'm going to kind of do like this. So I'll show you 1, 2, 3, 4, 5, 6, you know. You can test, sorry, 1, 2, take this off. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, sorry, 8, 9. And I think let's do 0 as well. Pin 0. Yeah. So now I've just configured 10 pins like this. Okay. This is an array. I'm setting up the array, but for the coding side, it's quite easy actually. So if I just define an integer, and I would say for I equals 0, I less than how many pins we defined? We defined 10 pins, haven't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 pins in here, and I'm gonna say 10 pins over here, allowed, and down there I'm going to say 10. Yeah. Just do an into a loop, and then take that off, chuck it in there. 1. Okay, so now this should power up everything, and I will do similar, just copy the thing again, and I will do off. So the first loop will switch all 10 pins on, the second loop will switch all 10 pins off. And what I'd like to do as well, I'd like to put a delay in there. So if I do a OSAL delay of 2000, I think OSAL is, yes, OSAL delay 2000, that's good. This may not work actually, but I'll explain that in a minute. So now we are delaying. This is like delaying Arduino. So you're doing that, and then you're waiting for 2 seconds, and then you're doing that, and you're waiting for 2 seconds, and the whole thing will end. I think I would, yeah, let's just keep it simple. Let's just run this now and see how it goes. But you get the idea. Let's focus on the pins whilst we are compiling. Now we got 1, 2, 3, 4. So only pin 2 and pin 4 are up, or pin 1 and pin 3, because we start from 0. So build finished, looks good. And I'm kind of looking forward to see, are we going to see any pin changes, yes or no? Did we or did we not? I don't think we did. So, now, yep. So now, we're gonna keep doing this stuff in here. Let me just make sure. Yeah, I did I0 and then I1. That's correct. Yeah. Yeah, so now, as opposed to this, yeah, that's fine. I will be doing all the pins. So rather than typing it all in and then changing it manually, I already typed it in on one of my screens here somewhere. So 144 pins, I'm chucking it down at this. So now I have all the 144 pins done this way. Yep. And then 144 definition, and then here on the for loop 144 and then 144. Sorry. And now let's run it again. I expect the LEDs to change now. There we go. See that? Did you see the LEDs? They're gone off. They got switched off. But what is the problem? The problem on this side is the OCell delay is not really working, because OCell is not really waiting for 2 seconds. It's just going straight ahead and then doing the stuff as we said earlier. It's all because we did not really tell it to use the BIOS yet, and this is where the issue is. So rather than doing OCell delay, let's just create another function. Let's just do a void delay, you know, and let's just say int duration. Yeah, and in an ideal world, I would like to have that there that says delay. Let's do it like this. Move that to the function instead. I know it means nothing right now. Nothing will change yet. But delay, because we are doing something else. So now I'm just going to remark this one. And I'm just going to int I and int j. Let's just call a loop. So for I equals 0, I, let's just do a 10,000. And then the same thing for j as well. For j, and then j. And we just do nothing. We'll just, so this is now, let's do a 1, 2, 3, 4, 5, 6, yeah, should be fine. So now we are kind of introducing a delay by having a loop inside, which does nothing. I know it's a crappy way of doing things, but just bear with me on this one. It'll all make sense in a minute. So let's change this to duration to take the value from here. So now duration will control how many times we're gonna loop this, whatever. So let's put something small. Let's put let's just say delay 20, and I'm actually put it inside the loop. Let's just do delay 1. Yeah, and then here delay 20, and then here we're going to, sorry, delay 20. Yeah. This delay is not going to make anything anyway, so we'll see. So now let's just power up again and see what happens. But now you get the idea. So, oh, I should have shown you the screen, the smaller one I developed. Sorry, I'll kind of touch on that. I'll get back to it in a minute. So now, after we compile, after it runs, I expect to see the LEDs kind of changing slowly, or taking a little time to change. Yeah, see that? Number 1 is on, number 2, number 3, and number 4. See that? Yeah. So you see now we got this up and running, and now they're gonna kind of switch off. There we go. They're powering down now. 1. Should power all down, hopefully with this loop. Yeah. Yeah, see that delay 20 is a lot. So if I were to delay 1 over here, it makes more sense. So 20 is a long time, apparently. Let's put this to 10. What I also like to do as well, actually, if I print F output now switching on LED number, and let's do an I here, and we'll do the I, and we'll also, sorry, switching off LED number I, right? So I'm going to run this code again, and now you'll start to see how close we are getting there. So I might need to slow this down even further by having a delay of 2, not just 1. Oh, what's going on? Oh yeah, sorry. We forgot la semicolon. Semicolon is here. Good. Run. Go back and then try. Oh, sorry. I keep doing this. Back to this screen. Okay. Let's just take you through what I've done already. So I don't think you've seen, you might have missed this part. What I've done is, you remember we had only 1 pin in the past. Now I've kind of copied it and created the array that does all the pins. So from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, blah, blah, blah. And then we're carrying on this way until pin 144, which is the last pin in the array. Yeah. And then also we said we are using 144 pins in the array for the pin configurations. We're using them all as output, and we're only using 1, which is nil, for the callback, and we are keeping the default of priority. So, and also what we did is I've done a for loop that says switch the thing on, switch all the lights on. By every time you switch something on, tell me which one you switched on, and then wait for a little bit. Once everything is on, wait for a little bit more, well, 10 times more, and then start switching them off, and then wait a little bit every time you're switching them off. So this will give me an estimate, well, kind of really which pin are we kind of talking about, or which pin, you know, close as possible. So if I run this now, you'll see how nicely this will run, and things will start to make sense. Okay. So now when you see the console on here, it will start to say switching on. Yeah, so now you can see the LEDs are coming up. The problem what we did is going this way, which is you know, the scroll is going right, because what we forgot to do, so just going back to the code, the stuff is actually outputting, but it's going this way, not one new line each. So what we need to do is we just need to put a /n at the end of this line, and another /n. And to be honest, I would rather want to delay a little bit more, so at least I can see. I don't want it to go too quick, so I'm just going to do it again. So run. Now focus on the board, and let's see what happens. So here we go. You can see now we are outputting things. So from 0 to 5. Oh, hang on a minute. Why is it only to 5? I'm expecting the rest of the stuff to come up. Yeah, the console is not really writing much in here. Weird. Nah, not to worry. If the printf isn't working nicely in here, what we can do is we can just UART printf. This will output to the serial instead. It's probably easier to read. But I think the UART printf doesn't like that stuff here. So what we need to do is number and I, and then, well, let's just do it this way anyway. Let's just see how it goes. Let's run this now. So now we'd expect to find this stuff running on the serial port, but now you get the idea, you know. So let's just clear the screen on the terminal and wait. I should see on this terminal now. Yeah, there we go. Okay. The error here indicates, that's what I was trying to do earlier. The error means it doesn't like this percentage and then I in here at all. So what I need to do is we need to take that off, and just do this printf. I can do another printf like that. Yes, convoluted, I know, but that is it. And rather than just letting it do it once, what I'll do, I'll loop this. So if I can just do here for and I take this off there and then chuck it in the loop, right? And then run it. Now it's going to be continuous loop. Don't know if I'm going to clear the screen. So now it'll give me an estimate of where these pins are. The minute I see, you know, pin X is coming up, pin, you know, on this and that, I should be able to find out. The warning is basically means some stuff not going to be used because we are looping, which is fine. So it means the function is going to keep going without ending. So that's the warning is about, which is fine. So now, here we go. Yeah. So now you see the LEDs, but for some reason, okay. The printf can take hex. Okay, I understand. Okay, fine. Right, now this is not really giving me the numbers because for some reason that printf is taking I and converting it into binary and then chucking it there. So that we're not really, you know, reading much out of it. So what I'll do, sorry. Right, okay, let's go back to this one. UART printf. number 02, this is 08 and then X for hex, right, and then slash n, and then comma I, take those off, and this is off. What I'm doing here is I'm saying I'm formatting 8 digits, hex code, and then using I this way. If I don't do X, it'll try to do integer I, which is a binary of I, which is not right what I want. I really want to see the pin number, and that's not helping. So just going to compile one more time, and now we are good to go. I just quickly read the reference manual for the print UART printf function. So now, rather than having this gibberish stuff, we should see the numbers coming up as we want. Moment of truth. Let's clear the screen. There we go. Nice, look at that. So we got the pins, now it's counting nicely, so pin whatever. And you can see, if you just keep an eye on the LEDs to see which ones are off, you can just guess estimate, you know, where we are actually with this. So let's look into 0, 1. So I've got, I'm nearly 10, maybe between 8 and 10. And the next one, yeah, around about 40 something. And then the last one, yeah. So okay, so we got an idea. All right. So now we're gonna cut things down and then make them quicker. So what we do now, we know, you know, we kind of guessed where things going to happen, and what we need to do now. You can also do size off in here. So rather than doing 144, you can do, let's just pick this array in here. That's your array of pin configs. You can do a, just to be on the safe side, size of I think size off will return, let's not complicate things. Let's just keep it to 144. Keep it simple. 144. We'll kind of slow things down. So let's just say we're taking these off. 8 and 9 we're keeping. 10 we're keeping. We were about 40 something. Let's start from 30. Then 30. Then 40. Then 50. Keep those in. 60 we're deleting. We're around let's just say 100. Take 120 off and all the rest of them. Yeah. Now, because you are really going into, you know, memory and stuff like that now, I think you really should start thinking of using size off instead to get more accuracy. Otherwise, your counter will start doing stuff on the run out of index at some point. So yeah, basically you need to make sure you get this right. So how to get the size off on these things? So rather than having 144, 10, because you don't really know how much pins we have in here. So what we're going to do, we're going to define number of pins equals the size of our array, which is Mr. Pin stuff, divided by the definition of it. So this will be size of pin let's just get the size from here, which is the definition of of that. Yeah. So now we are defining this, and also a number of interrupts. Yeah, is exactly the same thing. So we are taking this guy, sorry, this one here, dividing it by that one there. Really simple stuff. And then instead of having so instead of having it like this, now we're going to say that, sorry, my wife is just calling, give me a second, I'll be back in a minute. Oh, sorry about this. My wife needed some help. So anyway, right. So where were we? Yeah. So what we're doing is we're defining a number of pins to see how many items in this array, and because each of those elements is four bytes or integer, you take the 4 bytes in each one and you divide it by the definition of each, which will give you the number of items in there. So it's basically whatever this is divided by 4 will give you the right figure. What is this? Yeah, it's fine. Oh, interesting. Didn't press any button. Anyway, so yeah, so this is now, we've got number of pins and number of interrupts. And yeah, so now we have number of pins and number of interrupts as well. Just putting it there. Right? And what we'll do, we'll use that one for now to reference. So instead of having sort of for the iteration, this one here, instead of saying 144, we are actually spot on the money, number of pins, defining it this way. So this should definitely work better. And now we're going to get a lot less, you know, clear the screen. Actually, I want to slow it down even further, to be honest with you. I'm going to do slow down to 5. And in here, slow down to 5. Now, why do we have an error there? Interesting. Why am I having this error? GPIO. Could it be that? That can't be the semicolon. There's no way. So size of this divided size of that. Size of this divided by the size of that. Let's try this. Yeah, I know hash define does not require semicolons, surely not, but just in case. Oh, yeah, let's get an error again. That's being stupid, sorry. Delete that, delete that. Now they don't require, stop it. Yeah, delete this too. The problem when define, you don't need an equal sign, you need a space. And that's how it works. This is the define, not equal, yeah, that's it. That's the problem. So run again. Now let's see. The moment of truth. Yeah, looks like we're going through. And this time we're going to be running slower and a lot less pins, and we should still see the 4 pins going on and off in a circular motion. But you do get the idea. Every time you shrink down the number of pins, increase the timer. So there we go. So yeah, there we go. So did you see that? Let's just focus on this one. Yeah, there we go. So it's not working. Let's just take this down. I don't know if you can see this. Don't think you can, but it doesn't matter. Let's just put this in anyway. So, notice the pins. I'm going to read it out for you. So I'll wait for pin 1 to start. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 1 is there. Pin index there. Yeah, that's fine. So, to be honest with you, now we are firing on all cylinders. Now we have all the 4 pins. So 1 is coming up, 1 there, 2, 3 and 4. So you can tell 3 and 4 are very next to each other, but 1 and 2 are very, very further apart. And that's the thing. Anyway, I'm going to save you time, and you know, I'm not going to cheat, but what I'm trying to say is I've already worked them out myself by cutting these down gradually. To be honest, what you can do if you want to be you know, to do it the nice easy way, you can just say, for example, I'm going to remark this bit until here, and gradually you're going to enable and disable some pins in there until you get the right pins. So let's just do this now. And this is the way you kind of you can work out which pins are on and which pins are off, or you know, regardless of which board you have. This method should work for any board really, and it will you know, you should be able to where's the mouse gone? Where is my mouse? There we go. Okay. Yes, now let's just take this down a bit. Like this. Good. Clear the screen. Thank you very much. Now there you go. See that? Yeah. So, to save you time, I've already worked these out myself already, doing this method by, you know, enabling, disabling stuff. The pins in question are, let's just look at my notes in here somewhere. Yeah, so it's 9. But you get the idea. So it's actually 9. 44. 108 and 109. 108, 109. And the rest can go away. So we've got 4 pins in there. So 9, 44, 108, 109 is the pins you need. So if I run this again, yeah, now you're working with 4 pins only. I'll clear the screen in a minute. Still building, but we'll wait. Yes, no, I'm almost finished. Clear screen, thank you. There we go. Thank you very much. There we go, look at that. See the lights? Nice, isn't it? Just in case you're missing this, there we go. Yeah, so I think that kind of concludes our video today. Sorry it took a bit of a while. It's 1 hour and 20 minutes. Just see if I can cut this down at some point, I don't know. But yeah, I mean, you get the idea. What we did today is kind of, I don't think there's any video or any documentation on doing this online whatsoever. I don't know, I'd like to think I'm the first to do this, but this is to help you if you are using any board like that to kind of understand where the LEDs are and power them off, on and off if you're using a TI OMAP or the AM572 or the whatever AM board you have. This method will work because it's standard on all CCS. So hopefully that would help you. Thank you very much for watching. The next video will do the input pins, which should be a lot quicker now because we already define a lot on the GPIOs and all that kind of stuff, and I might do the same video. I might include the tasks and the other bits and pieces I'm actually working on, or did finish earlier. But I mean, you get the idea. Hopefully this video would help you. Thank you for watching, and hopefully you will have a nice day. So I'll see you later. Bye bye.